Hello, today I'll be talking about the angle of depression. The angle of depression is defined as the angle formed or constructed by a horizontal line and a line joining the object and the observer's line of sight when the object is below the horizontal line. The angle of depression. Here we have the horizontal line, and then we have the line connecting the object and the observer's eye, and then we have the vertical height and the horizontal distance. The angle formed between the horizontal line and the observer's line of sight is theta. So theta is the angle of depression. So let's take an example to illustrate our point. The angle of depression of a vehicle from the top of a tower on the ground is 60 degrees. If the vehicle is away from the building at a distance of 100 meters, find the height of the tower. Let's see the solution. From the diagram, we have that h all over 100 is equal to tan 60 degrees. And from our trigonometrical ratio, we have that for special angle, 60 degrees is equal to root 3. So putting it in the equation, we have h all over 100 is equal to root 3. So meaning that h is equals to 100 root 3, which is the height of the tower. Please do subscribe to our YouTube channel at Increasers_Academy for more of our videos. Press the subscribe button, the notification button, so that we notify you each time we have a new video. Don't forget to press the subscription button. Subscribe now. Let's take a general example that concerns elevation and depression. Example 2. From the top of a tree of height 13 meters, the angle of elevation and depression of the top and the bottom of another tree are 45 and 30 degrees respectively. Find the height of the second tree. We represent this problem diagrammatically. From the question, let's take this as the height of the first tree, which is 13 meters high. Then let's take this as the other tree. Then the angle of elevation of this tree, of the top of the first tree to the top of the second tree, taken to the horizontal, is 45 degrees. While the angle of depression from the top of the other tree to the bottom is 30 degrees. If we complete the diagram, we have something like this. And from our knowledge of geometry, we see that this 30 is alternate to here. So here is 30 degrees. And this is the height of the first tree. This is the height of the second tree. This is the distance between the first and the second tree, which we don't know. So we may call it x. And then we know that from our properties of plane shapes, that if you have a rectangle, that the two opposite sides are equal and parallel. So here is 13 meters as well, which is the opposite of this other side. So we now have to find the distance between the first tree and the second tree, which is x meters. from our trigonometrical ratio, we have that 13, which is the opposite, all over x, which is the adjacent, is equal to tan 30 degrees. We have that tan 30 degrees is equal to 1 all over 3. So putting the value, we have 13 over x is equal to 1 all over root 3. So that our x is equal to 13 root 3. So 13 root 3 is our value of x, which is also equal and parallel to this other side. So here is 13 root 3. Now with the 13 root 3, we can now find the value of y. Let's call it y. So from here, we now have that. For us to find y, we use y all over 13 root 3, which is the opposite over adjacent, is equal to tan 45 degrees. So giving us that y is equal to 13 root 3 times tan 45 degrees. We know that tan 45 degrees is equal to 1. So meaning that y will be equal to 13 root 3 times 1, which is equal to 13 root 3. That is the value for the y. Y is equal to 13 root 3 times 1, which is equal to 13 root 3. So this is the value for y. Our y plus 13 is equal to, our y here is 13 root 3 plus the 13 meters, which is the value for the height of the small tree. So that will give us that the value for the height of the big tree is 13, factor out 13 from both sides, bracket root 3 plus 1. So this is our value for the height of the big tree. Thank you for watching our video.